The big question of the day is, how do we figure out where to put a trend line, right? You always watch a teacher go up there and just throw a trend line into a scatter plot. How in the world did they know where to draw it? Well, the secret is residuals. Today, that's exactly what I want to talk about. So what I mean by this is if we were looking at plants, right? You've always wondered about how they grow. So we have their age here and their size. And we have just all these data points telling us how they've gotten bigger. And it does look like over time, they do get bigger, right? So where do I throw the trend line in? I can just throw one in, okay? That looks about right, but is that the best line? I mean, what makes a line the best line? Could the trend line be here? Could it be up here? Which of these three is the best, and why is it the best? Okay, let's answer that question today. So to do that, we need to think about residuals. I want us to think about 4 things about residuals. And I'm going to start with this first one here, how to find one. So just how do you find the residual? Okay, so to find one, let's look at this example here. We've got percent of wins, so that's our explanatory variable. That's always down here. And then our response variable here is attendance. So the question is, these are all Major League Baseball teams. As percent of wins increases, how does attendance respond to that? Does attendance increase? Now, looking at the scatter plot, it does kind of look like, it does look like positive. So let's throw a trend line in. Is this the right one? Well, to do that, we're going to need to measure residuals. So let's figure out how to find the residual. What we do is let's just look at 50% wins. Okay, at 50%, our trend line predicts that 33,000 people will attend. Does that really happen? Well, our data point right here says not exactly. Okay, what really happens is way up here. So the distance between our actual, which is right here, that's blue, that's what we would just call y, and our predicted, that's this red point here on the trend line, and that's y hat, that's going to equal our residual. It's our error. I know we use the word residual, but a residual is just the mistake we've made, right? How off we are. Sometimes it's really big. Right here, it would be quite small. Here it would be even smaller. So how you would find that is you just use this equation here. So here's a different example. We've got houses for sale. We're going to predict that we can predict the price of a house by looking at its size. That's X, using this equation. So let's look at a real situation and find a residual. In the real situation, we had a 1,000 square foot house and it sold for $125,000. What is the residual? Okay, so a 1,000 square foot house here selling for 125. Let's put it into this equation to find it. So you stick the X value into the equation. We get this as our predicted amount, and then you go to the residual equation, which is our actual 125 minus our predicted, and here is the residual right there. So that would be the distance between predicted and actual. All right, so that's our first thing we need to know. Now let's go to the second thing, what that residual represents in the big picture. So if we go back to this baseball example, we know all the residuals, and what they're telling us is that if we looked at the equation that we put in here for this trend line, and we figured out our R squared, say it was 60%. That 60% tells us that 60% of the change in attendance per game is caused by as a result of the change in the percent of wins. Awesome, 60%. But there's another percent we don't know. There's a bunch of the change, 40% of it, of that variation, that is explained by the residuals. So I did say residual there. 40% of the change, the stuff that is not explained by the equation, is actually explained by residuals. So the total residual shows the amount of variation in y that is not explained by the regression equation. R squared is the percent of variation in y changed by x. That's what we want to try to figure out. But what's left over, 1 minus that percent is what the residual shows us. So here I have 2 extremes. I have this extreme where we have 100%. R is 1, so R squared is 100% of the change right here is explained by our trend line, in which case there's no residuals. Okay, the percent exchanged by residual is 0. Here's the other extreme. Okay, 0%, R is 0, so R squared is 0% is a change by the trend line. So here in this extreme, actually all of the variation is due to something we don't know, the residuals. All right, so let's look at the third thing we want to look at now, how to use residuals to find a regression line. All right, so right here I'm looking at distance flight. Does distance help us predict how much it costs to actually fly in an airplane? So I have these data points. What we do to figure out the true trend line is we just throw in any old trend line that we think will work. So I've just thrown this trend line in. And I want to look at the residuals for this idea of a trend line. So I draw in my residual right here. And the problem with drawing in a residual is residuals can be positive or negative. And I always want to be positive. So how you make a number always positive is you simply square it. So I'm going to turn this residual into a square. So if it had been 5, I'm going to actually think of it as 25. All right. And doing squaring it also allows me to really put a lot of attention on these larger residuals, which I want to avoid. Now I'm going to make these squares for every single residual I've got. So every single one I've built little squares around. And then once I've made all these squares, which is I've found the distance and I squared it, I'm going to add them all up. So I can look at my total residual, or my total residual square to be totally accurate. Now after I do this, I'm going to draw another line across, okay? And I'm going to use this equation again, and I'm going to add up all the squares for a different line. And then I'm going to draw another line, make squares, and add up all those. And I'm going to look at the sum of squares for each of these lines that I draw. And then I'm going to pick the line that has the smallest sum, the smallest total residual. That's how I find my trend line, okay? I can call that trend line a lot of things you've learned. There's just, we say trend line, that's what Excel uses. We also use regression line. Best fit line you probably used a lot, maybe in 8th or 9th grade. Linear model. And the last thing we call it is least squares line. And I love this line right here, this name, because it totally captures what it is, right? This line is picked by finding the line of all the possible lines that can be drawn that has the smallest squares, right? The least squares line. So that is how we pick our regression line. And please remember that it can be called all of these different names and they mean the same thing. All right, so now we've learned 4 things. Let's go to the, 3, sorry, let's go to the 4th one, how to use residual plot to check the straight enough condition. So residuals, we need them for one more thing here, checking conditions for linear regression, right? If I want to do linear regression, I need to make sure that it matches 3 conditions. The conditions are down here. Straight enough, quantitative, and no outliers. Or if there are outliers, I find them and remove them. Now these 2 are not too bad. I can look and see if X and Y are quantitative. I can look at my scatter plot to check on outliers. Straight enough can be a little tougher. Is this scatter plot straight enough? Okay, really think about it. Can we trust what we see? Are our eyes good enough to say if that is straight? Because there's a lot of things that might look straight, but they're actually like exponential, parabolic. What's really happening here? We actually can't trust our eyes. So to figure it out, we need to do something called a residual plot. So to do that, what we do is we first just make a basic scatter plot right here. I do throw in a regression line. All right, and once I throw that regression line in, I make what's called a residual plot, and Excel can do this for you. And here's how it does it. It takes any point right here, and it figures out the residual, that distance, all right? And then it goes over to here with the same x-axis, okay, so we're a little over 40, and what it does is it goes to 0 and it plots down. It looks, okay, so this was about, a -7 units or whatever it was, and it goes down and does the same thing right here. Then it goes to another point over here, a little bit above 40, and then it takes that distance and it plots it right over here. So what we end up with is just a scatter of all the residuals coming from 0. Some are above, some are below. And this is exactly what I want to see, a big fat scatter, just randomness. That would let me know that yes, in fact, linear is the best for this model. But let's look at some situations where that might not be the case. What if my residual plot looked like this? Is this random? Take a close look. Actually, it is not a random scatter. I don't know if you can see it, but there's a slight kind of like U-shape, parabolic shape in here. So that would mean no, I'm not going to do linear regression, and I would stop doing the problem right there, because in this class we haven't learned how to do other regressions. Now this one, on the other hand, this does look scattered. I don't see a U. I don't see something that maybe looks like kind of a sideways V coming out. So it's random. I can do the regression. Right? So a scatter plot showing all the residuals for each x value, and you want to plot it if it's random. If it's not random, do not use a linear regression. So let's look at 3 scatter plots. The scatter plots are up here. Of these 3, which one do you think is straight enough based on their residual plots? Does this have a pattern? Does this have a pattern? Does this one? So here actually is the only one that is random. Here, this actually does have a pattern. I don't know if you can see it's kind of a sideways V. It actually comes out somewhat. So that would be no. Here we had that U, so that would also be no. Let's look at these. I'm going to look at just residual plots. I have 6 residual plots. Which one is connected to a scatter plot that really is almost straight or straight enough? So if you look at all 6, the only one that is really random is here. So this is the only one that I would actually do a linear regression on. Again, I don't do a linear regression on this. What I do is I just check this and then I go back to my actual scatter plot and do the linear regression on that. So these are the 4 things that you do need to know. Make sure they're clear for you and write down what you need and look forward to the next topic.